Hi guys, my name is Terry. In this video, I'm going to go through with you the Form 4 Additional Mathematics textbook question for Chapter 1 Intensive Practice 1.3. If you enjoyed this video, kindly like, subscribe, or leave us a comment if you have any question. So let's get started with question number 1. In this arrow diagram, we have function f that maps x onto y and function g that maps y onto z. So first part, we are determining the value of f2. Now f2 means we start from 2, we go through function f, you arrive at 5. Okay, second one, g5. g5 means we start from 5 here, we go through function g, we arrive at 8. Okay, how about GF2? GF2 means we start from 2, we go through function go through function F, so we arrive at 5, followed by function G, you arrive at 8. Part D, you have F inverse 5. F inverse 5 means we start with 5, we go backwards. Now remember, fx will map x onto y. F inverse map y onto x. So we're just going in the opposite direction. We start from 5, we move back to 2. Answer is just 2. Okay, next one, G inverse 8. Okay, let me rub this off. G inverse 8 means we start from 8 here. We go backwards, you arrive at 5. Remember, inverse is moving in the opposite direction. Your g goes from y to z, g inverse will go from z to y. Okay, the next one we want to do f inverse g inverse 8. So we already know g inverse 8 map onto 5. Now follow on by f inverse. F inverse means you're going in opposite direction here. You arrive at 2. Okay, simple, right? Okay, question number 2. By applying horizontal line test, determine whether each of the following function has an inverse. Now remember, we use vertical line test to determine whether the type of relation, whether it's one-to-one, many-to-one, so that we know a particular relation is a function or not, right? But when you want to do in this case, horizontal line test, we are actually working on the opposite. Remember, a function will have an inverse if it's one-to-one, right? So in this case, we cut across. You notice it cut at one point, so you will have a one-to-one relation. Yeah, the what do you call that? The opposite. Yeah, one y map onto one x. So this function x will map onto y, y will map onto x. It's a one-to-one relation. Yes, it will have an inverse. Okay, the second one you cut across here. Can you see? There's only one point that it cuts through, right? So it is also one-to-one, so it has an inverse. Okay, the third one you notice you cut across, right? It has 3 points, 3 different points here. So there are 3 different x values that map onto one same y. Yeah? So when you go backwards, when you map y back to x, it's not a many to one becomes a one to many. So it is not a one to one, so it doesn't have an inverse. Okay, that's question number 2. Let's move on to question number 3. Diagram shows a graph of one-to-one function. So one-to-one means they definitely will have inverse. In each case, sketch the graph of f inverse, hence state the domain. Okay, remember when you put inverse graphically, the graph is a reflection in the line y equals x. Okay, so if you want, you can add this line. Normally, we will show this line. Okay, but in this case, a bit small for you to see. Right, this is the line y equals to x. Okay, normally we represent it using a dotted line. So for inverse, I'm going to use a red line. So we're just going to draw the reflection like this up. Okay, so make sure this is a perpendicular distance. When you go from here to here, can you see it must be the same, the perpendicular distance across must be the same. And another thing is the coordinate of your x and y must be reversed. When you inverse it, your 2 becomes 4, 4 becomes 2. Now we can actually imagine this way. Original function f maps 4 onto 2. The inverse function will map 2 onto 4. So it's just going in the opposite direction. Okay, so remember you need to show your coordinate there. Becomes 2, 4. So what happened to your domain? Okay, remember the domain of your f inverse is actually the same as the range of your fx. But since we already drawn this, we can see quite clearly your domain is measured from here to here, right? Which is from 0 to right? Okay, next let's look at B. We draw the line of reflection first. I'm going to use blue line here. Right in the middle, this is your line of reflection y equals x. Okay, when you inverse it, or the graph, I'm going to use a red color. 4 is going to move over to the other side. 2 is going to move over to this side. Yeah, your 2 map onto the opposite side, 2 on the other side. So I'm going to draw this line here. Okay, now not too long because it starts from 2 here all the way to 4. Oh, my line is not so straight, man. It's quite gay. Here, all right. Now, there you go. And make sure it just cut through the middle line there at y equals x. It must pass through y equals x. Okay, so what is your domain? Your domain is 0 to 4. Yeah, the domain of the red line, the f inverse. You can see the minimum is 0, the maximum is at 4. Okay, the next one, part C. Let's draw your y equals x here. Okay, let's draw the inverse. The inverse I use red color, so this one is curving up. In fact, C and A, they are exactly opposite. If you notice, they're exactly opposite. They should intersect here, and this point is now, instead of 4 8, we write 8 4. Okay, and what happened to your domain? What's your domain? Your domain is measured from 0 to 8. So we say your domain of your f inverse is now 0 to 8. Okay, all right, let's move on to question number 4. The graph of fx is now, function fx is now 2x. We can write here fx is 2x plus h over x minus 3. And you're supposed to find the value of h. Now, given that when you sub x with 4, your fx is now 13. So let's put 4 inside plus h over 4 minus 3. The result is 13. 2 times 4 is 8. So 8 plus h. 4 minus 3 is just 1. So I don't have to write that, right? You divide by 1, you still get 8 plus h. Bring 8 over 13 minus 8. H is just 5. Okay. Second part. You're supposed to find f inverse 3. Okay, now I would like to share with you guys my way of inversing. I'm using the old textbook method. Now the new textbook method, as you know, the new textbook we're using is we always let fx becomes y. Then you have to inverse the function, then you substitute. Now for me that is a bit long because you have no choice but to inverse the function. So for me, I always let the whatever I'm finding, which is f inverse, in this case is f inverse 3, I let it be y. So the idea is this, let's say I start from 3, I go backwards, let's say I end up at y. Now when I start from y, I move forward, I end up at 3. So we can always interchange your object and your image. Your object initially is 3, your image is y. But when you interchange, because you're going in the opposite direction, your object is now y, your image is now 3. I'm going to sub this inside your function fx. Now that I know h is 5, so I'm going to write 2y plus 5, y minus 3 equals to 3. Okay, remember, this is, if I put x here, this will be x and x. If I have y here, over here, everything else must be in y. Yeah? So this is 2y, and this is y minus 3. So our goal is to find what? Our goal is to find f inverse 3, which is y. I need to find y. So let's multiply over 2y plus 5 is 3y minus 9. Bring the 2y to the right, bring the 9 to the left. Y is just 14. And what is your y? Your y is your f inverse 3, and your answer is 14. Okay, not too difficult. Now if you wish to use the textbook method, we let fx becomes y, find the inverse function first, then you sub inside. You still get the same answer, but it's just a lot longer. Right, so next, find the value of m when f inverse m equals to 2. Now again, a lot of people are going to inverse a function. Again, you don't have to inverse a function because you know that if you have f inverse m equals to 2, we can interchange f2 is now m. Right? We switch the position of your object image, and straight away your inverse disappear. We just write f2. And what is f2? f2 simply means we put 2 inside your function f here. Again, now I know my h is 5. All right, this is 2 minus 3. So 2 times 2 is 4. 4 plus 5 is 9. Right, 9 divided by negative 1. M is just negative 9. Yep, I think it's a lot simpler. All right, let's move on to question number 5. The inverse function h inverse is defined by this. Find hx. Okay, remember, your textbook always state whatever you're finding, let it be y. Right? Whatever you're finding, let it be y. Sorry, whatever you're given, sorry. Let's say, for example, you have fx. You're given fx by. Okay? Now, this is the current textbook. Yeah? For me, I always let whatever I'm finding becomes y. But let's say you're given the inverse. You are finding function h. So I would now use whatever I'm finding. Okay, I'm finding hx. I let it be y. Then I will interchange y and x. Right? Remember, if this is x, you map onto y, and if you start from y, you inverse it, you get back x. So here we know our h inverse is 2 over 3 minus x. So we write 2 over 3 minus y, since this is y. Okay, here there are two ways of writing. Okay, number one, of course, I actually like to switch the position, as in I bring my x down, I bring the whole 3 minus y up. Yeah, this whole bracket I bring up, x I bring it down. Yeah, then you bring the negative y to the left. I hope you can see this, and bring this over. So y is now 3 minus 2 over x. And what is your y? Your y is your h. You're finding hx, I'm not h inverse. Your y is your hx. Here, can you see your y is your hx, which is 3 minus 2 over x. And we say x cannot be 0. But I know a lot of people don't like this switching method because they find this is a bit more confusing. Okay, so you can use the second method, which is the answer from the textbook based on the second method. We cross over and write 2 equals 3x minus xy. Okay, I'm multiplying this whole thing up. Yeah, the whole bracket at 3 minus y times x. Bring the xy over, bring the 2 over. Xy is now 3x minus 2. Your y is 3x minus 2 over x. And my y is hx, which is 3x minus 2 over x. Again, we write x cannot be 0. Your denominator can't be 0. Now notice there are two different answers. Are they actually different? No, they're actually the same, because we can split this. For example, 3x over x, 2 over x is actually 3 minus 2 over x. Yeah, it's actually the same. Just that the second one, we put it together as a single fraction. Okay, so both are also correct, but I think the textbook answer given is this. Okay, all right, B. Find the value of x such that hx is now 2. Again, I am a bit lazy. I don't want to sub in my hx value, because I think you can just switch h inverse 2 equals x. Remember, switching the object and image. So your 2 is now your object, x is now your image, and you write h inverse. Alright, let's put 2 inside this h inverse here. So you get 2 over 3 minus 2 equals to x. X is just 2. Okay, simple. Alright, moving on to question number 6. Okay, here we have two functions, fx and gx, that are defined by fx equals 4x minus 17, gx is 5 over 2x minus 7. So we are finding the solution to this equation, f inverse equals g inverse. Okay, so here we have to inverse both, right? So let f inverse x equals y. Again, I want to say this, you want to use the fx equals y, go ahead. I'm just showing you f inverse x equals y. So fy equals to x. Yeah, I let whatever I'm finding becomes y. I switch the position of x and y. And then we write 4y minus 17 equals to x. 4y is x plus 17. Y is x plus 17 over 4, and my y is my f inverse, which is x plus 17 over 4. Alright, next I'm going to find my g inverse. I'm going to let g inverse x becomes y. Gy is now x. Okay, so 5 over 2y minus 7 equals x. Now here again, you can choose to switch the position, or you can multiply one by one. But I don't want to show you too many, so I just show you the second one. Yeah, 2y minus 7 and multiply by x. one by one. Let's find y. So I bring the 7x over. So 2xy is now 7x plus 5. Okay, and from here we divide by 2x, 7x plus 5 over 2x. This will be my g inverse. We write 7x plus 5 over 2x, x not equal 0. Okay, actually you don't have to write the x not equal 0 because we don't need to show this answer. What we want is to solve f inverse equals g inverse. Okay, this one is a bit ugly. My x looks a bit ugly. Let me fix this. Alright, so let's take f inverse x plus 17 over 4. Let it be 7x plus 5 over 2x. Alright, and from here, now I don't like to cross multiply 2 because I can see a 4 can divide by 2, left with 2, right? So now only we cross multiply, x times over is x squared plus 17x. The 2 I times over, 7 times 2 is 14, 5 times 2 is 10. This is a quadratic equation that we can rearrange it. Bring 14 to the left, 17 minus 14 is 3. Bring 10 to the left, you get minus 10. And now we can double bracket factorize it. So what is the factor of 10? 5 and 2. So I'm going to put 5 and 2. The bigger number positive, smaller number is negative, but it's minus 2 plus 5 gives us positive 3. The times together, let it be 0. So the solution is x plus 5 equals 0. X is negative 5. X minus 2 equals 0. X is positive 2. Alright. Moving on. Question number 7. Farida carried out physical activity during her leisure time. So then Farida calculated her estimated heartbeat using the function where x is her age. So determine the inverse of this function. Okay, so to inverse this function, we let f inverse x becomes y. Fy is now x. So 17 over 20, 220 minus y is now x. 220 minus y is 20 over 17x. Okay, let us make y as a subject. Bring this over, right? So your y is now 220 minus 20 over 17x. So we rewrite this as f inverse 220 minus 20 over 17x. There you go. Next one, if Farida's age is 16, determine her heartbeat rate. Okay, I don't think you need to use the inverse. You use the inverse, you're wasting time because what we want is her heartbeat, which is f, right? What we're given is her age, which is x. 16 is x. So if you want to estimate her heartbeat, just put 16 inside this original function here, 17 over 20, 220 minus 16. That'll be a lot faster. Use your calculator, 173.4. Alright. Okay, let's move on. This will be the last one, number 8. Zaki intends to make a spherical water ball that can hold half cm cube of water. The volume here is given by this V equals 3 pi r cube, where r is the radius. So Zaki wishes to know how to determine r if V is given. Draw arrow diagram that shows, okay, arrow diagram. So I'm going to draw arrow diagram that map your r onto V. So this is r mapped onto V. So using the function f and the inverse function f inverse that maps V onto r. Oh, I'm done. Alright, very simple, right? Okay, next one. Hence, determine the radius of the ball that can hold the volume of water according to the specification. So actually, you don't have to, you don't have to really inverse the function. You write the inverse function because we already know that basically if you're given V, you're finding R, we're just rearranging it. We are rearranging the equation. So you can write like this. We can say that, okay, 4 over 3 pi r cubed is now your V. Okay, now what is a V that you want? You want half, correct? you can even say like this one. If you want to write in the function notation, we can say that your function fr is now v, right? So okay, so your f inverse v must be r. So you need to inverse this. If you want, you can inverse this, but the volume that we want, but actually wasting time, the volume that we want is half. So we can say f inverse half is now r. So I'm not like, let's say I'm wasting time because I'm like rewriting this. Am I right? So we know the function is 4 over 3 pi r cubed equals half. So you can skip all this line here. You can skip all these because actually it's not necessary to find r. So your r cubed is now 3 goes up, 4 goes down. So you get 3 over 8. The pi goes down, and then you cube root it, right? Cube root. Now use your calculator. You should get 0.4924. But if you round off the textbook, use 2 decimal, your answer is 0.49. Alright, okay, yeah. So you enjoyed this video, and you like, you know, perhaps get more practice, right? We have a lot of workbook, modules, e-learning videos, and so on, right? Or you can, if you're interested, can join our class. Just get in touch with us or find our book from our Shopee site, right? Thank you very much. See you in the next video.